In today's lesson, we will review the AS Level Physics, and I will start with paper 1, the multiple choice questions. Number 1, a crane has an arm to which is attached a frictionless pulley. A cable passes over the pulley and supports a load of 10 kilonewtons as shown. The crane arm exerts a force F on the pulley, and we want to find the value of F given the options. First of all, we have to see that here the value of F will be equal to the resultant of the tension forces. So if we want to find the tension force here, I will draw the free body diagram of this load, and there is the weight force 10 kilonewtons, and there is tension here, which is the same as tension there. Because this system is in equilibrium, then the tension here will be equal to 10 kilonewtons also. So to find F, we'll have to find the resultant of two factors, 10 kilonewtons and 10 kilonewtons, and there is an angle of 60 degrees between them. So use this equation, F equals the square root of t squared plus 2 times t times the cosine of theta, where theta is 60 degrees and the tension each is 10 kilonewtons. So that you will have you will calculate that the force F will be 17.32 kilonewtons. So the answer will be D. Number 2, quantity X has a fractional uncertainty of X, quantity Y has a fractional uncertainty of Y. What is fractional uncertainty in X over Y squared? To answer this question, we have to remember that when performing multiplications and divisions or dealing with powers, we simply add together the percentage or the fractional uncertainties. So if we want to find the fractional uncertainty in X over Y squared, then we'll just have to add together X plus 2 times Y. So the answer is C. Number 3, two balls of masses m and 2m traveling in a vacuum with initial velocities 2v and v respectively collide with each other head-on as shown. You have to see the direction here. After the collision, the ball of mass m rebounds to the left with velocity v. We want to find the loss of kinetic energy in the collision. First, I want to draw the condition after the collision. So this m is moving backwards with the velocity of v, and we have to find the velocity of this object after the collision, and we don't know the direction also. So first we have to write down the conservation of momentum. m1 v1 plus m2 v2 equals m1 v1 prime plus m2 v2 prime. Let this be mass 1, let this be mass 2. So m1 is m multiplied by v1, which is 2v, plus m2 is 2m multiplied by v2. It should be negative v because the direction is to the left, opposite to the direction of the first object. It will be equal to m1, which is m, plus v1 prime. v1 prime is the velocity of the first object after the collision, and it is negative v because it is bouncing back to the opposite direction. So m times negative v plus m2 is 2m, and this is v2 prime, the velocity of the second object after the collision. So from here I can cross m out. Then I can find that v2 prime will be equal to v2 prime equals v over 2. And if we want to find the lost kinetic energy, that means that we have to find the total kinetic energy before the collision and the total kinetic energy after the collision. Before the collision, we have kinetic energy equals a half m1 v1 squared plus a half m2 v2 squared. This should be squared, yeah? So it is equal to a half times m times 2v squared plus a half times 2m times v squared. This is the velocity of object 2 before the collision. And that will give us the total of 2mv squared plus mv squared equals 3mv squared. After the collision, we can find kinetic energy by using the same equation, a half m1 v1 prime squared plus a half m2 v2 prime squared. So it is a half m times v squared. We don't have to mind the negative sign because it will be squared, plus a half m2 is 2m multiplied by a half v squared. This is v2 prime. So it will be equal to a half mv squared plus a half multiplied by 2 is 1, but a half squared is 1/4. A half plus 1/4 is equal to 3 over 4 mv squared. So the loss in kinetic energy is 3 mv squared minus 3 over 4 mv squared. It will be equal to 12 over 4. 3 is 12 over 4 minus 3 over 4 mv squared. So it is equal to 9 over 4 mv squared. So the answer is C. Number 4, a uniform horizontal beam OX 4 meters long and weighing 100 newtons is hinged at a wall at point O. It is supported by a cord XY which is attached to the wall at Y. What is the tension of the cord here? You are given options. So first I have to draw all the forces that act on the system. Our system is the rod, so there is the weight of the rod, which is 100 newtons. And I have the tension of the cord, which acts on the rod. This is it, the tension. And I want to resolve this tension into Tx, which is T times the cosine of 30 degrees, and Ty, which is T times the sine of 30 degrees. Actually, we have several forces that act at this O, but I will just take this O as my point of reference, as my axis of rotation, so that I can eliminate those unknown forces. So the resultant of torque about O should be equal to 0 because this system should be in equilibrium. So the resultant of torque will be 0. The resultant of torque is caused by this weight, which is positive because it will turn the system clockwise, multiplied by perpendicular distance from the line of action of force to the axis of rotation, and that will be a half of the length of the rod from this point O to that force 100 Newton. So weight times a half L, and then we can see that we have T times the cosine of 30 and T times the sine of 30, but T times the cosine of 30, it will go through the axis of rotation, so it will not create any torque on the system. We will find that T times the sine of 30 degrees will create torque on the system, and it will bring the system to rotate anti-clockwise. That's why we give it negative sign. Negative T times the sine of 30 degrees multiplied by the line of action of force to the axis of rotation. The distance is this L, the length of the rod. Yeah, it should be equal to 0. So I can cross L out, or if you want to substitute this using 2 meters and that L using 4 meters, that will be okay. That will be the same. The weight is 100 multiplied by a half equals T times a half. So you can calculate that T is equal to 100 Newton. So the answer is D. Number 5. Two parallel metal plates have a potential difference between them of 12 volts. The distance between the plates is 1 millimeter, and we want to find the electric field strength between the plates and the work done on a certain charge, given the charge, to move the charge from the negative plate to the positive plate. We'll just have to memorize the equation that E is equal to V over D, and that V is 12 volt. D is 1 times 10 to the minus 3 meters, so you get 12,000 volt per meter. The unit of E electric field strength can be volt per meter or Newton per coulomb. That will be the same. Yeah, work done is equal to Q times V. V is the potential difference. So Q is the charge here, positive 3.9 times 10 to the minus 6 coulomb, microcoulomb, times the voltage. The potential difference is 12 volts. So you can calculate and you'll get 4.68 times 10 to the minus 5, and that will be equal to 4.7 times 10 to the minus 5 joules, and the answer will be C. Number 6. A distant star is receding from Earth. This word receding means move further away from a previous position, yeah, from the Earth with a speed of 1.4 times 10 to the 7 meter per second. It emits light of certain frequency, and the speed of light is given. And it is stated that the Doppler effect formula can be used with light waves. So when we want to find the frequency of this light when detected on Earth, we will use the Doppler effect formula. Yeah, I will draw a diagram here that when this is the Earth and I have a star receding from the Earth, moving further away from the Earth with the velocity of 1.4 times 10 to the 7 meter per second, this will be the source of light. So I can label this Vs. And Fs, the frequency of the source of light, is 4.57 times 10 to the 14 Hertz. And of course, the frequency of this light when detected on Earth will be FO, of the observer. And you know this equation will be given. Yeah, you know that F of the observer equals V over V plus Vs multiplied by Fs. That V is the speed of light, 3 times 10 to the 8. So I can calculate by substituting those quantities, and then I can calculate that the F of the observer is 4.366 times 10 to the 14 equals 4.37 times 10 to the 14 Hertz. So the answer is B. Number 7. A car of mass 1,400 kilograms is traveling on a straight horizontal road at a constant speed of 25 meters per second. The output power from the car's engine is 30 kilowatts. The car then travels up a slope at 2 degrees to the horizontal, maintaining the same constant speed. What is the output power of the car's engine when traveling up the slope? Of course, because it wants to maintain the constant speed, but it is traveling up a slope, then it needs extra power. Yeah, when the car is traveling on a horizontal road, the weight is directly downward, and it does not contribute in opposing the motion of the car. Along the slope, this is the weight, there is weight times the sine of 2 degrees. This is the component of weight that opposes the motion of the car. Yeah, so the output power of the car's engine should now be greater. Yeah, this is another component, but this component which opposes the motion. So we need to find out the extra power required by the car on the slope. We know this equation, P equals F times V. So the F is 1,400 multiplied by 9.8, that's the weight, multiplied by the sine of 2 degrees, multiplied by V, 25 meter per second. It is equal to 11,970.53 watts, and this extra power is needed to maintain the constant speed that is opposed by the component of weight. Yeah, so the total power should be this 30 kilowatts, 30,000 watts plus this value. So it is 41.97 kilowatts or equal to 42 kilowatts. Yeah, so the answer is C. Number 8. A coil contains n turns of insulated copper wire wound onto a cylindrical iron core of diameter capital D. The copper wire has a diameter D. I want to draw some diagrams here. This is the diameter of the copper wire, small d. And this is the diameter of the cylindrical iron core, capital D. And then the resistivity of copper is given, rho. Diameter D is much greater than the diameter this small d. We want to find the total resistance between the two ends of the coil. I will describe it like this. I will wound on the copper wire here to the cylindrical iron core. We assume that there is no gap between the wires. So the length of the copper wire that is wound onto the cylindrical iron core will be equal to the number of turns multiplied by the circumference of the cylinder. So that will be, the number of turns is n, capital N, multiplied by the circumference of the cylinder is pi multiplied by the capital D. So it is n pi d. So the area of cross section of the copper wire here will be equal to pi d squared over 4. And because R equals rho times L over A, I can substitute L using this n pi d divided by the area of the cross section of the copper wire, pi small d squared over 4. So R will be equal to 4 n rho capital D over small d squared. We can cross pi out. The answer will be A. Number 9, two cells are connected to a load resistor of resistance 3 ohms. The EMF and the internal resistance is shown. What is the current in the load resistor here? First, you are given some options. We are using the second Kirchhoff's law here. So first of all, I will draw the direction of current that is flowing through the load resistor. And the current will be shown here by the green arrow. This is the current. And after drawing the direction of the current, I will draw the direction of the loop. The direction of the loop, I give it the same direction as the direction of current. Number 10, a radioactive nucleus is formed by beta decay. This nucleus then decays by alpha emission. Which graph of proton number Z in x-axis plotted against nuclear number N in y-axis shows the beta decay followed by the alpha emission? So we know that proton number Z and nuclear number N will be conserved. So during beta decay, alpha is helium 4-2, beta is beta 0 minus 1. During the beta decay, the proton number of the new nucleus will increase by 1. The nuclear number remains the same. During the alpha emission, the proton number of the new nucleus decreases by 2 and the nuclear number decreases by 4. So I will write down the equation. So if I have the nucleus will be symbolized by this X. Yeah, it is formed by beta decay. So it is formed by this beta decay. So the proton number of the new nucleus will increase by 1 here. Now, this nucleus then decays, so X will decay by alpha emission. So it will emit alpha, becomes B. So later, this X, the proton number will decrease by 2 and the nuclear number will decrease by 4. So from these 4, the most correct one, I think it is this one, because first it is formed by beta decay, so the Z the proton number will increase by 1. So it is from 91 to 92. And then the proton number decreases by 2 from 92 to 90, but the nuclear number will decrease by 4. So before it was 234, now it is 230. So the answer is B. I think that is our review for today. Tomorrow I will continue another review. So if you have any questions, you can ask. Thank you for your attention. I hope this video is useful. We will use the second Kirchhoff's law that the sum of EMF is equal to the sum of potential difference, and when I follow the direction of the loop and I find the positive terminal of the battery, I will give the EMF negative sign. -6 and then here -3 should be equal to the sum of I times R. It is I, this green arrow, and it will go through this 0.8 plus 1.2 plus 3.0 ohms. So the sum of potential difference will be I multiplied by 0.8 plus 1.2 plus 3, which is equal to 5. So I will be equal to -9 over 5. It is minus 1.8 amperes. This negative sign, I think you don't have to mind that. We'll just have to find the value of the current, which is equal to 1.8. The answer is C.